Next chapter is chapter number 25, that is the spatial and the temporal data mobility, or how to use the temporal and the data mobility, and how to use the spatial and the data temporal data, and how to mobile, or how to use the data, and how to we can share the exchange the data between the spatial and the temporal data. So this chapter is basically on the basis of the database that is used, that is relatively simple, and that is used for the support of the different types of versions of the SQL. Over time, however, they are developed, increasing the need for the developing or handling the more database in the data type, that is the data is available in the temporal data as well as we can say the spatial data and the multimedia data. So whenever we use the database, whenever we use a complex database that is available in the temporal data, spatial data and the multimedia data. And the another major trend that is it's created its own issues, that the growth of the mobile computers. So whenever there will be a growth of the mobile computers, that is also a major trend that is used in the database connectivity, that is used in the database we can say the database activity. Starting with the laptop computer and the pocket organizers, and extending in the most recent years to mobile phones with the built-in computers and a variety of wearable computers that are increasingly used in the commercial application. So whatever the commercial application, whatever the usage that is used with the various issues, that is used with the growth of the mobile computer, that starts with the laptop computer and the pocket organizers. In this chapter, we study several aspects or several data types and the other issues that is dealt with these applications. That is, what are the various issues that is available in this organization, or that is available with this database management system. The first part is motivation. So before we address the topics in the detail, we shall consider the motivation, that is what are the various motivation parts and what are the various issues that is deal with the various types of or these types of data. So what are the various motivation part, or what are the various issues? First is the temporal data. So first part is the temporal data, that is the most database system model the current state of the world, for example current customer, current student and the courses currently being offered. These are the database system, that is the temporal data that is used. For example, the database systems, or for example the current student, that is what are the various current customer, what are the very current student that is available, and the courses that is currently being offered. And in many applications it is very important to store and retrieve the information about the past state. So historical information can be incorporated into the schema definition, that is known as a temporal data. Then the spatial data, that includes the geographical data such as the maps and associated information, such as when we combine, or when we can say that when we combine the data, when we represent the data with the use of the graphs, with the use of the computer aided designing technique, that is known as the spatial data. That is used for the circuit diagram, that is used for building the design, that is the spatial data. So one is the temporal data, that is the historical data. One is the spatial data, that is the geographical data, that is used with the computer aided design data. Applications of spatial data initially stored data as a file in a file system, as it is used with the early generation business applications. And the spatial data applications require facilities offered by a database system. So whatever the database system, whatever the facilities that is available, that is offered by a database system. In particular, the ability to store and query the large amount of data efficiently. Some applications may also require other database features, such as the atomic updates to parts of the data or stored data, durability and the concurrency control. In section 25.3, we study the extensions needed in traditional database systems to support the spatial data that is required for the database connectivity that is required in the traditional database systems. Next is the multimedia data. So one is the temporal data, that is a historical data. One is the spatial data, that is a graphical representation of data. One is the multimedia data that is required in the database system, that stores the multimedia such as the video, audio and the audio data, that is the images, audio, video data that is also available in the database system. The main difference, or the main important feature of the video and the audio data is the display of the data during the retrieval, that is how to display the data during the retrieval at a steady predetermined rate, and hence such data are known as the continuous media data, that is a multimedia data. Then next is a mobile database, that is the next part, that is a usage of the mobile database, that is the next device, or that is the next data that is used in the database connectivity. So in this part we study the database requirements of the mobile computing, such as the laptop and the notebook computers, that is how to use the laptops and how to use the mobile computer that is used in the database connectivity, or that is used for storing the data. And the main limitation is that they have a limited storage capacity and thus require special techniques for the memory management, that is a mobile database. Next topic is time in the databases, that is how to manage the time or how to represent the time in the database. So a database model the states of the some aspects of the real world outside itself. Typically database model has only one state, that is the current state of the real world, and do not store the information about the past state, except perhaps as audit trails. When the state of the real world changes, the database gets updated and the information about the changes will be still available or they get lost. So when automatically the new changes are occur, the old changes will be, we can say, the updated or will get lost. However, in many applications it is important to store and retrieve the information about the past state. So it is very important in the many applications, that is how to store the data and how to retrieve the data that is available in the past states. For example, a patient database must store the information about the medical history of a student, that is when the patient comes, what is the first disease, then what is the second disease, and how many diseases are available or are captured by the or are given to the patient. So database that stores the information about the states of the real world across the time. So whenever we store the data about the real world of a time, that is known as a temporal databases. And when considering the issue of the time in the database that is used, it is used in the database management system, that is used with the database connectivity. So when the database store information about the state of the real world time, that is known as the temporal databases. And when considering the issue of time in database system, we differentiate between the various time. So one is a valid time, that is a time interval during which the fact is true in the real world, that is what is the fact and how to use the real world scenarios. Then the transaction time, that is the time interval during which the fact is given in the current database, that is within the database system, that is a transaction time. And later time, or that is this transaction time, is the transaction serializability, that is how to use the transaction serializability and how to use them with the database connectivity. That is the transaction time. Then the temporal relation is the one in which where each tuple has an associated time when it is due. That is the temporal relation that is used in the database connectivity, that is used in the database medium, that is used with the, we can say, the database enable, that is used in the database connectivity. That is the temporal relation, that is on the temporary basis the relation will be maintained in the databases. This is the one of the example, that is a relation is given, table is given, that is a temporal instruction relation. This is the ID, then the name, then department name, salary, then from and to. So this is the ID, that is a unique one, then name, that is the name of the employee, then the department name of the employee, then the salary of the employee, and what is the duration of the we can say the tenure of the person that is available in the company, that is a from the to. So this is the ID, then the name, then the department name, salary, and the from to, that is a temporal instruction relation. Then next is the time specification in SQL, that is what is the time specification in SQL and how to use the time specification in the SQL, that is available in the database connectivity. So the SQL standard defines a type, that is the date, time, and the timestamp, as we saw in the chapter number 4. So there are multiple criteria while specifying the time, that is the time specification, and the type data or date contains 4 digits for the year, that is a 12999, 2 digits for the month, that is 1 to 12, and the 2 digit for the date, that is a 1 to 31. And the type time contains 2 digits for an hour, and the 2 digits for the minute, and the 2 digits for the second. So this is the criteria, that is how to specify the time in the SQL. The second fields can go beyond the 60 to allow for the leap second that are added during the some year or during the year that is used to correct for some variations that is used in the speed of the rotation of the earth. And the timestamp contains the field of the data and the or date and the time, that is with the available with the 6 fractional digits for the seconds field. And since different places in the world have different local time, there is often for specifying the time zone along with the time. So there is also specifying the time zone, because there are different speed, different local timing that is available with the different countries. The universal coordinated time, that is a UTC, is a standard reference point that is used with the database connectivity. That is a standard reference point for specifying the time with the local time defined as a offset from the UTC. That is a UTC, that is a universal coordinated time, that is written in the French as a universal time cordon. SQL also support two types, that is the time with the time zone and the timestamp with the time zone. We specify the time as a local time plus the offset of the local time from the UTC, and that is written with the 6, or we can say the various intervals. SQL supports a type known as the interval that allows you to refer a period such as the 1 day, 2 day, or the 5 hour. That is the interval, that is a, we can say, the gap between the various interval of the timing that is available in the database connectivity. Then the next is temporal query language, that is how to use or what is the meaning of temporal query language. That is on the temporary basis the query will be given, that is a temporal query language. A database relation without temporal information is sometimes known as the snapshot relation, since it reflects the state in a snapshot of the real world. Therefore, a snapshot of a temporal relation at a point in the time t is a set of the tuples in the relation of the point t. So that is a time interval that is given, that is a temporal query language that is used. And temporal selection is a selection that involves a time attribute, that is what are the various time attributes, how to use the time attribute, and what is the temporal relation or the projection that is used where the tuple that is available inherit from the tuples in the original relation. That is a temporal join, that is joined with the intersection of various tuples from which it is derived. And the predicates precedes, overlap, and contains can be applied on the interval. Their meaning should be clear. That is a predicate that is available, and that is a temporal function relation that is used with the database connectivity. Next is the spatial and the geographical data, that is what is the meaning of the spatial data, and the geographical data. So what we study, that there are different types of data like the spatial data, multimedia data, and the temporal data. So next is the spatial and the geographical data, that is how to represent or how to use the spatial data and how to use in the geographical format. The spatial data supports in databases is important for efficiently storing, indexing, and querying of data on the basis of the spatial location. That is spatial data that supports in the databases, that is very important for the efficiently storing, indexing, and querying the data on the basis of the spatial location. For example, suppose that we want to store a set of polygons in a database, and to query the database to find all the polygons that intersect a given polygon, that is a polygon state, and we want to query the database to find all the polygon that intersects a given polygon. We cannot use a standard index structure such as the B tree or the hash indices to answer such a query efficiently. Efficient processing of the above query would require special purpose index structure such as the R tree for the task. Two types of spatial data are very important. So there are two types of data that is used to represent the data in we can say the graphical format or the computer aided design format. So there are two types of spatial data that is very important. That is a CAD data, that is a computer aided design data, which includes the spatial or the spatial information about how objects like the building, cars, or the aircraft are constructed. That is on the basis of the computer, that is a computer aided design that is used, that includes the spatial data that is available about the how the objects are formed and how the different objects like the building or the cars or the aircraft are constructed. Other important example of computer aided designs are the integrated circuit and the electronic device layout. That is what are the integrated circuit and how to use them with the different layout that is available with the database connectivity. That is the spatial data, that is one of the example. Next is the geographical data that is also represented, such as the road maps, land usage maps, topographic evaluation maps, political maps. So if I want to represent the map in a database, that is involving the maps in the database, that also shows the boundaries, land ownership maps, and the so on. Geographical information system are special purpose databases that is tailored for the storing the geographical data. And this is also support for the geographical data that has been added to the many database systems such as the IBM DB2, Spatial Extender, the Informatic, Spatial Data Log, and the Oracle Spatial. Then next is the representation of geographical or geometric information. That is how to represent in a geometric information. So this figure, or we can say the figure 25.2, this is one of the figure that represent the geometric constraint, that is how the different geometric constraints will be available. So that shows various geometric constraints that is represented in a database in a normalized fashion. We stress here that geometric information can be represented in several different ways, only which some of which we describe. First of all, a line segment. That can be represented by the coordinates of the endpoint. That is, whenever we draw the line segment, that this is a line segment, there are two endpoints, that is a 1 and the 2, and they are expressed or they are defined or they are, we can say, the built with the radius or with the line segment. So line segment can be represented by the coordinate of its endpoint. For example, in a map database, the two coordinates of a point would its latitude and the longitude. A polyline, that is also known as a line string, that consists of a connected sequence of the line segment and can be represented by a list containing the coordinates of the endpoint of the segment in the sequence, that is a polyline. And we can approximately represent an arbitrary curve by the polyline, that is represented with the polygons, that is represented with the various natural polygons. And then we can also represent in the order that is available. We can also represent in the diagonal relation, or we can also represent with a triangle that is used. And this is the various representation that is used with the database connectivity. So the representation of the points and the line segment in the three-dimensional space is similar to their representation in two-dimensional space. The only difference being that point have an extra G or extra Z component. Similarly, the representation of the planar figures such as the triangle, rectangle, and the other polygon does not change much when we move to the three dimension. That is, it does not represent when we move to the three dimension. Tetrahedron and the cuboid can be representing in the same way as the triangle and the rectangle. This is the line segment, and there is a triangle. This is a polygon. This is another polygon that is represented in the diagonal format. Next is the design database. So one is a CAD that is used, and next is the design databases. Now CAD traditionally stored data in the memory during editing or other processing and wrote the data back to a file at the end of the session of the editing. So whenever the session is end, it is available in the data file, that is available in the data storage, that is stored or wrote the data back to the file at the end of the session of editing. The drawbacks of such a scheme includes the cost. So whatever the drawback that is used, that includes the cost, that is the cost is very high of transferring the data from one form to the another, and the need to read in the entire file even if only the parts of it are required. And for the larger designs, the large scale integrated circuit or the design of an entire airplane, that is impossible to hold the complete design. So designer will use the database requirement of the CAD systems. So the object-oriented database represent component as an object. So we can use the object-oriented databases in which the components are represented in the form of the objects, and the connection between the objects indicate that is how the design is constructed. And the object that is made, that also involve the geometric object and simple two-dimensional object that will be used, that will include the point, lines, triangles, rectangle, and generally the polygons. And the complex two-dimensional data that is also available in the database connectivity, that is used in the database, we can say the figure that is used in the database connectivity for storing the data in the database usage. and that is known as a wireframe model that can also be represented with essentially model the surface as a set of the simple object and such as the line segment, triangles and the rectangles. And a design database also stores non-spatial information about the object. So whenever we design the databases that will store the known object or that will store the non-spatial information about the object, such as the material from which the objects are constructed. We can usually model the relation, we can usually model the information by the standard data modeling technique. And there are various spatial operations that will be performed on a design. There are multiple operations that is also available on the design, that is the spatial information. This is one of the example of the spatial information, that is the difference of the cylinder, that is the union of the cylinders. Thereby keeping the design constraint or consistent, and implementing such integrity checks again depends on the availability of the efficient multi-dimensional index structure. Now next is the geographical data or geographic data that are spatial in nature but different from design data in the certain ways. Maps and the satellite images are example of the geographical data, that is how to represent the map and how to represent in a satellite images, that is also one of the example of the geographical data. Maps may provide not only location information about the boundaries, rivers, but also one of the example that gives the detailed information about the elevation, soil type, land uses and the annual rainfall. That is the geographical data that is represented in the form of the graph, that is represented in the form of the bars, chart, that is the geographical data. Now next is the applications of geographical data, that is where the geographical data will be used. So it has a multiple applications, multiple uses that includes the online map services, vehicle navigation system, distribution network information for public services such as the telephone, electric power and the water supply system, and the land usage information for ecologists and the planners, that is how to use the ecologists, who is the ecologist and how to use them with the database planners. And web-based road map services form a wide variety or very widely used application of the map data. And at the simplest level, these systems can be used to generate the online road maps of a desired region. So this is one of the, we can say, the application that is used. And the vehicle navigation systems are systems that are mounted in the automobiles and provides roads maps and the trip planning services. They includes a global positioning system that is the GPS unit, which uses the information broadcast from the GPS satellite to find the current location with the accuracy of the tens of the meter. So there is accuracy that is given with the satellite that is available with the tens of the meter that is used in the database connectivity. And the GPRS or the GPS unit that finds the location in terms of the longitude and the evolution and the navigation system that is used to find where and on which the roads of the vehicle is currently located. Then geographical database or the geographic databases for public utility information have become very important as the network of buried cables and pipes have grown. Now there are two categories, or we can say the representation of the geographical data. So geographical data can be categorized into two types. There are two types of the geographical data that is available. One is the raster data. Such data consists of the bit map or the pixel maps in which two or more dimensions. So there are multiple pixel bit map or the pixel map that is available in the two or more dimensions. A typical example of a two-dimensional raster image is a satellite image of an area. In addition to the actual data or actual image, the data also includes the location of the image, that is how to locate the image and how to represent the image in a database format, that is specified by the latitude and the longitude of the system that is used for the various systems. So raster data is often represented as a tiles that is also covering a fixed size area, and the last area can be displayed by displaying all the file that is available that can overlap the area. Next is the vector data that are constructed from the basic geometric object that is used with the geometric objects such as the points, line segment, polygons and the triangles and the other polygons in the two-dimensional shape. So whenever we represent the data in a trigonal form, cylinder form, sphere form, cuboid form, that is available in the three-dimensional form. And this is another application, another we can say the alternative that is used to represent the data that is available in the pixel. So what is a pixel? First of all, that is a geometrical boundary, or we can say the geometric dots that is available in the data that is used for the raster applications, or that is used for the raster representations in the development. Now, however, the vector representation is unsuitable for the applications where the data has or data are instrictly raster based, such as the satellite images. Next is the topological information, that is the information about the elevation, that is the height of each point on a surface, that can be represented in a raster form. So that is the topological information, and that is available in the TIN, that is a triangulated irregular network. That is a compact representation which is particularly useful for generating the three-dimensional views of an area. Then geographic information systems usually contain both the raster and the vector data, and can merge the two kinds of data when displaying the results to the user. For example, map application that usually contain both satellite images and the vector data about the roads, building and the other landmarks. And the map display usually overlay the different kinds of information. For example, the road information that is used, that is also a geographical information system. And it is also interesting to note that even information that is actually stored in the vector may be converted to the raster scan before it is converted to the user interface. And there are many, we can say there are map services that is available, like the Yahoo Map and the Google Map or the Yahoo, that also allows the database connectivity that is used to specialize the data that is used in the map display, and contains the application specific data that is also used to standardize the, we can say, the provide the standard to the map data. Now next is the spatial queries. So there are a number of queries that involve the spatial location. So whenever we want to generate the geographical data or get the geographical data, so there are multiple queries that is run on the spatial location, that is run on the spatial queries, spatial data. One is the nearness queries that request the object that lies near a specified location. So these are the object that lies near a specified location. A query to find all the restaurants that lie within a given distance of a given time is an example of nearest or nearness query. So whenever the query that is used to find the restaurant that lies within a given distance of a given point. So whatever the distance that is available in the given point, that is an example of nearness query. The nearest neighbor query requests the object that is nearest to a specified time. For example, we may want to find the nearest gasoline station, that is used to limit on a distance, and then we ask that an idea, that is how far the nearest gasoline station lies. That is the nearness query. So that is also nearness query that is given, that is how much distance or location will be available, or data will be available, or we can say the content will be available, or location will be available. Then the reason queries, that is also deals with the spatial reasons, that is what are the various reasons. For example, one of the reasons that is available with the geographical boundaries, that is a query that is used to find the retail shops. And the query that is also requires the intersections and the union of the reasons. For example, given reason information such as the annual rainfall and the population density, that is what is the annual rainfall and what is the population density, that is a query that may request all the reasons with the low annual rainfall as well as the high density path. So this is a query that requests or that includes various reasons or all the reasons with the low annual rainfall as well as the high population density. And the queries that compute intersection of the reasons can be thought of a computing of the spatial joins of two spatial relation. For example, one represents the rainfall, one represents the population density. Now next is the indexing of the spatial data, that is how to maintain the indices or how to maintain the indexing in the spatial data. So they are required for the efficient access to the spatial data, and the traditional data will be available in a available form. One is the KD trees, that is used to understand the three dimensions that is used. This is the division of a space in the KD trees. Then the quad trees, this is another example, that is the quadratic trees is also formed. Then the R trees, that is the trees will be formed in the R format. And we can also implement the insert, update and the search in the R tree, deletion also. This is a various operation that is available on the trees. Now next is the multimedia keys, that is how to use the multimedia keys and what are the various content that is available in the multimedia. Okay. So we are finished with the temporal data. We are finished with the spatial data. Now the next database, we are finished with the temporal database or the temporal data, spatial data, and now there is a chance, or there is a, we can say, the number of the multimedia database. So I'm just coming within 2 minutes, then start this session, that is the multimedia database. So next is the multimedia databases, that is what is multimedia databases and how to use the multimedia databases. So multimedia data, that is the images, audio, video are increasing popular form of data that are used almost stored or almost always stored outside the database, that is in a file system. So whatever the multimedia devices, whatever the multimedia data that is available, for example the audio, for example the video that is available in the database connectivity, or that is available in the database for the various operations, and these are lies beyond the database that is available. And this kind of storage not a problem when the number of multimedia object is relatively small, since features provided by the database are usually not important. However, database features have become when the number of multimedia objects is large. So whatever the database feature that is available, that becomes important. Whatever the database connectivity that is available, that is used in the database connectivity, that is used for the database management. And the multimedia objects often have a respective database attribute, such as for the indicating whatever they are created, whenever they are created, and how they are used, that is a multimedia database. And one approach to building a database for such multimedia object is to use databases for storing the descriptive attributes and for keeping track of the files in which the multimedia objects are stored. And however, storing the multimedia objects or outside the database makes it harder for to provide the database connectivity functionality, such as indexes or indexing on the on the basis of the actual multimedia storage content that can be used for the inconsistency that is available in the database connectivity. And the several issues must be addressed if the multimedia data are to be stored in the database. So there are multiple issues that must be addressed if the multimedia data are to be stored in the database. The first point is the database must support the large databases or large objects, since multimedia data such as the video can occupy up to the few gigabytes of the storage, and so they do not support the object that is larger than the few gigabytes. Then the next point is that retrieval of the some kinds of data or the some type of data such as the audio and the video has a requirement that as a delivery must be proceeds at a guaranteed steady rate, and such data are sometimes known as the isochronous data or the continuous media data. For example, if the audio data are not supplied in the time, there will be a gap in the sound. If the data supplied are too fast, then the system buffers may overflow, resulting in the loss of the data. Now, third point is similarity-based retrieval is needed in many multimedia database applications that is used. For example, in a database system that stores the fingerprint images, a query fingerprint image is provided, and the fingerprint in the database that are similar to the query fingerprint must be retrieved. Now next is the multimedia data format that is available, like the JPG, MPG, or the MPG, JPG, and the moving picture expert group, or the joint photographic expert group, that is the MPG and the JPG. And that has developed the standard for the multimedia application that is used in the database multiple features. And this is the JPG or the MPG, that is the motion picture expert group, that has developed with the various standard that is used for encoding the video and the audio data. And these encodings are also used as a sequence of the frame to achieve a greater amount of compression. So whenever we want to compress something, whenever we want to compress the multimedia data, that is compressed by using the two format that is most introducedly used, that is the MPG and the JPG. That is the motion picture expert group and the joint photographic expert group. And there are multiple formats that is used, that is the MPG1, MPG2, MPG4 that is used to compress the videos, audio that is available in the database connectivity. Then the next is continuous media data, that is the most important types of continuous media data, such as the audio and the video data that is used. And the continuous media system are characterized by the real-time information delivery requirement. So whatever the delivery requirement, whatever the database that is used, that is available in the database connectivity, that is a continuous metadata or media data. And continuous media data have a following requirements. The first is data must be delivered sufficiently fast so that there is no gap in the audio or the video result. That the data must be delivered in a efficient way, or data must be delivered sufficiently fast, though there will be a no time in the gap, there will be no time in the, we can say, the processing that is used in the database connectivity. So there will be a no gap in the audio or the video, that is one of the requirement that is used. Then the database must be delivered at a rate that does not cause overflow of the system buffer. So they must be delivered at the rate, and there is no cause of the overflow of the system buffers. Then next is there is a synchronization among the stream data or the data streams that must be maintained in the database connectivity. So there must be a synchronization that is used or that is maintained among the distinct streams that must be maintained synchronistically. And this need arises, for example, when the video of a person speaking shows some lips moving synchronously with the audio of a person speaking. So whatever the audio, whatever the database that is used, whatever the video that is used, that is available with the database connectivity. And to supply the data predictably at the right time to a large number of customers of the data, the fetching of the data from the disk must be coordinated carefully. And usually the data are fetched in a periodic cycle. So usually the data is available in a periodic cycle that is used. An each cycle, for example, of the n seconds that is used, that is fetched for the each customer and stored in many buffer. While the data is fetched in the previous cycle is being sent to the customers from the memory buffers. And the cycle period is of compromise, that is a short period that uses less memory but requires the most disk movement that is used in the database connectivity. And when a new request arrives, that there will be animation control that will comes into the play. That is, the system checks if the request can be satisfied or with the available resources or with the available data or not. And these risks are available in the database connectivity that is used in the database operation that is used for the database media players. And there will be extensive research that will be used, that is available in the database connectivity, that is used in the extensive probability of the data. And there will be extensive research that is used in the database connectivity that is used for the database features. And the basic architecture of a video on the demand system comprises. So what are the various requirements that is used in the database connectivity? So these are the various requirements that is used in the database connectivity that is available in the database system. So the several vendors offer video on the demand servers, and current servers or systems are based on the system files, because the existing databases also provide the real-time scenario. This is the basic structure that is used. One is the video server. Then the multimedia data are stored on the several disks, that is usually in the RAID configuration, that is the video server. Then the terminals, that the people view the multimedia data through various devices, that is used as referred as the terminals. And each computer will be used with a device that is known as the set-top box. There will be a network, so there will be requirement of the network, and the video on demand service cable over cable network is widely available. The next is the similarity based retrieval. So in many multimedia applications, data are described only approximately in the database. An example is the fingerprint data that is available in the section 25.4. The other examples are the pictorial data that is represented in the picture format. Then audio data, that is a speech-based user interface that is being developed, that allows the user to give a command. Then there will be handwritten data. So these are the various database or data that is used for the simple retrieval or similarity-based retrieval information. And several algorithms exist for finding the best matches to a given input by a simple or similarity data stream. Now next is the mobility and the personal databases. That is what is the mobility and how to use the personal databases, and how to, we can say, the mobile, or how to transfer the data, or how to use a personal database. So large scale commercial databases have traditionally been stored in a central computing facilities. In a distributed database applications, there has usually strong central database and the network administrator. So whenever we use the distributed databases, they must contain the strong database, or we must say that must contain the strong central database. So there will be connectivity in the computer. We can say there will be a strong database, that is they have available servers, available client that is used, and there will be a network administrator. So network administrator means there will be a network admin that is also available, that is used to handle all the controls. And there are multiple assumptions that is used to widespread the various assumption that is not entirely correct. So the widespread of the laptop, or the use of the laptop, notebook, or the netbook computer, and the widespread use of the cell phones with the capabilities of a computer. Then the development of the relatively low-cost wireless digital communication infrastructure that is based on the wireless local area network, cellular digital packet network, and the other technologies. The next is the mobile computing that has proved useful in many applications. For example, many business travelers use the laptop computers so that they can work and access data on the route. And that is the mobile computing that is used in the application, and most of the or many business travelers use the laptop computer so that they can work and access data on a route. Delivery services use mobile computers to assist in the package tracking, and the emergency response system that is used for the computer are used as the sense of the disaster. And then the wireless computing also creates a situation where the machine is no longer being required, and the battery backup is a resource for the fast computing. And then is a model of the mobile computing, that is how to use the mobile computing resources. Then there will be a model of the mobile computing, that is how to use the model of the mobile computing that is used. So the mobile computing environment consists of the mobile computer, that is referred as the mobile host, and a wired network of the computers. And the mobile host communicate with the wired network via computer that is referred as a mobile support station. So there will be a mobile support station that is used in the database connectivity, that is used with the database feature that is used, and they also available with the mobile host with the cells, that is the geographical area that it covers. So whatever the geographical area that is used, whatever the cells that is used to cover the geographical area that it covers. And the mobile host may also move between the various cells, that is a very necessity feature that is used in the database connectivity. And there is an end of feature that is used with the database connectivity, that is usually stored for the database features. Since mobile host may sometimes be part down, so host may leave one cell, and the one cell may be that may be materialized with the various view that is available at the distinct cell. So the cell may be available in the distinct manner, that is available in the distinct form that is used in the standardized format. So that may be a handheld computer, that may be a hand-off computer that is used. So there another technology that is also used as a Bluetooth technology, that is used as a Bluetooth. So there is no wire, there is no connection, only the Bluetooth data will be available in the database connectivity. And the wireless local area network based on the 801.11 standard are widely used today. In the system that is based on the 802.16, that is a WiMAX standard, are being deployed. And the network infrastructure for the mobile computing consists in the large part of the two technology, that is a wireless local area network and the packet-based cellular technology. That is, there are two network infrastructure that is used, and the early cellular systems uses the analog technology and were designed for the voice communication, that is used with the analog technology and the voice communication. Third generation, and known as the 2.5G, also uses the packet technology or packet-based technology. Bluetooth wireless LAN and the 2.5 cellular makes it possible for the makes it makes it possible for a wide variety of resources to communicate at a low cost. And there is another technology, the wireless form, that is a WAP, that is a wireless application protocol, that makes the wireless possible in the broadcast area. Then next is the routing and the query processing, that is how to route the query or how to route the processes, and how to query the or how to process the query, that is the routing and the query processing. The route between a pair of hosts may change over a time if one of the host or two hosts is mobile. So whatever the route that is available with the hosting, that is available with the database connectivity, that is used in the database feature, that is used for the various connectivity that is used in the database features. So the route between the pair of hosts may change over the time if one of the two hosts is mobile, and this is one of the dramatic effect that is available on the network layer. And what are the various, we can say the course that is used. One is a user time, then there will be connection time, number of bytes available, that is a various route broadcasting. Then again the same scenario, that is the broadcast data, that is how to broadcast, that is how to represent with the multiple computer, that is a broadcasting the data. So a mobile host can then receive the data that is transmitted rather than consuming the energy by transmitting a request. The mobile host may have a local non-volatile storage available to cache the broadcast data for the possible later use. And broadcast data may be transmitted according to a phase schedule or a change schedule that is available in the database connectivity. The next is the disconnectivity and the consistency, that is how to use the disconnectivity and how to maintain the consistency. So the wireless communication may be paid on the basis of the connection time, and there will be an incentive for certain mobile hosts to be disconnected for the substantial period. And the mobile computers without wireless connectivity are disconnected most of the time when they are created. And the situation may arise several problems in the disconnectivity and the consistency. One is the recoverability, one is the consistency. The consistency may be loose, or the data may not be recovered whenever the data will be failed. So that is the recoverability and the consistency. And there is a report that is given when a mobile host is connected, that is given an invalidation report that informs that is out of the cache version. So any problem that will be available with the report. And these are the various example of the version factor that is used in the various weaknesses, that is version factor or version scheme that is used in the database connectivity. Now this is the winding up of the chapter, that is a summary. The first part is time plays an important role in the database system, that is used as a database system, and that is modeled of the real world scenario. Whereas most database systems are model the state of the real world at a point of the time. So we use a temporal database, we may use the spatial database, and we may use the multimedia database. Facts in the temporal relation have associated times when they are valid, and which can be represented as a union of intervals. So whatever the fact that is available in the temporal relation. Then next is a spatial database that are finding increasing used today to store the computer aided design as well as the geographical data. And then next is the design data that are stored primarily as a vector data, geographical data, that is a combination of the vector and the raster data. And that can be encoded as a first normal form, and they can be stored using the non-first normal structure such as the list, that is a vector data. Then R tree, that is a multi-dimensional extension of the B tree that is used with the R plus tree and the R into trees. Then we also talked about the multimedia database that is used in the database connectivity, that is used for the delivery of the data. Then the mobile computing system that has become common, that is lead to interest in the database connectivity. Then broadcast, that is also cheaper in the point-to-point communication, that is used in the stock market, that is used to pick up the data in an inexpensive way. Then disconnected operation, that is using the broadcast data, and the caching of the data are the three important issues that has been addressed in the mobile computing. Then these are the review terms that is used. These are the practice questions, practice exercises. Then this is the bibliographic notes. Now next chapter is chapter number 26, that is advanced transaction processing, that I am going to start in the next class. So this is the chapter that shows what are the various advanced transaction processing modes. So this is the advanced feature that we are going to study. So what are the various advanced transaction processing mode that is used in the database connectivity. So that's all for today's session. Thank you so much everyone for listening me, and if there is any doubts, any suggestions, you can ask the doubts from me. Thanks a lot everyone. Bye bye. We will meet tomorrow with a new chapter, that is chapter number 21, advanced transaction processing. So thanks a lot. Bye bye.